concrete only differs in the procedures. It's not any different to many other concrete, the material, because it is all made up of the same four parts, which is the Portland cement, the sand, and the stone, which is in the concrete, and then water. Although we do alter, we change some of the proportions to make it work more for what we're trying to end up with an end result. So the procedure really is what the difference is, and the procedure comes to us pretty much in three parts. The three parts are, first of all, how do you build this form? Because the construction of the form really is one of the first key parts of making the concrete do what you see at the Pulitzer. The form work really loses any kind of resemblance to a concrete form in that it's so finished and you spend so much time and labor on getting the panels so perfect. We have to be always conscious of things such as leakage, both water and then air moving through the form, and making it move in only the places we want it to move. And then, of course, the procedure of putting the form together itself. So that's the first step. Second step is the mix design itself. That's the parts of the pieces of concrete. Even though the concrete pieces are all the same, it's how those portions go together. And with this type of concrete, we were always concerned with aggregate settlement, which is something that happens in the pouring procedures. If you don't keep the sand and the rock and the Portland cement in the correct mixture or in the matrix of the mix, you really don't have concrete. So that is what we were going for when we started to balance out stone content and the amount of sand in the mix, and then also how much Portland cement we wanted in there. We did things with, say for instance, the Portland cement, where we added, I think it was another 3/4 of a bag of mix of Portland cement, more than what the normal mix design would call for. And that was to help us generate a situation which is where the cement paste, that's the cement that is so fine, that's mixed with the fine sands, actually floats out, or you force it out against the form panel, and that really creates the finish on the concrete. There's no sand, no heavy sand in the finish on the surface. There's no rock in that surface because that's all inside the wall. But this cement paste is crucial, and you need to push it more and have a bigger concentration of it on the outside wall, and to create the finish, the really high finished concrete on the edge. Third step is pouring procedures. Pouring procedures, that involves, first of all, how you receive the concrete, the slumps that you pour it at. Real quick explanation of slump. Slump is the measurement of the content of water. The Portland cement needs a certain percentage of that to hydrate, but not all of it. So that means that when it's all done hydrating, the concrete itself starts to throw that extra water out. It's part of the process of the concrete setting. This is the bleed water, and this is the water you have to control, because this is where leaks start and things such as sand streaking, where the cement is being carried away through a hole in the form. So the bottom line is, if you can control the water at the very beginning, then you don't have as much to deal with when this process of getting rid of the excess water starts to take place in the wall. So slumps were watched really carefully. The next thing was the placing of the concrete. And the standard wall form was 12 feet tall. And we chose to do it with 3 bands of concrete, so that's 4 foot at a time, basically leveling it out in the form as you're progressing up. The pouring is really critical as far as or the placing is critical as far as how you do this, because you simply don't want to drop a bucket full of concrete through 12 feet of rebar and then have it's completely separated at the bottom, because that's one thing that will happen, is that once that rock starts to bounce off the steel, it's simply shaking the cement off the rock and the sand, and of course that's the glue. And if you lose the glue, the wall won't stay together. So the way that's done is with a device that we nicknamed, it's called an elephant's trunk. And really all it is a vinyl tube. That the vinyl tube is attached to the bottom of the bucket or to a hopper that you're dropping the concrete through. And being that it's vinyl, it's simply letting all the concrete slide past that reinforcing steel, and it's placing it right at the bottom of the wall where it needs to be, and nothing comes apart. So now the concrete is being placed in layers, and you've got to consolidate it. This is where the concrete vibrators come into play, not only for the consolidation of the concrete itself, but also then to start to eliminate a lot of this trapped air that you're going to get in all concrete. The danger is that if the bubble floats out to the outside surface of the wall, of course now it shows when the wall is stripped. So procedures were developed and levels were hit so that we could control, and I guess stress the word control, the aggregate settlement, because we did get some aggregate settlement. And if you're not careful, you can simply have a 12-foot wall with all rock at the bottom, sand in the middle, cement on top. That's not concrete, and it's not durable. I would say we were a good year and a half into the pouring. We had worked through all those situations where it almost became like a choreographed ballet up on top of that scaffolding. It was quite remarkable in the fact that once I had experienced people on the wall, people that knew exactly what the next step was going to be, it just was a great thing to watch.